spectroscopy will enable scientists to study the composition of the stars way past what? Two things: observational capacity and hands-on study capacity. So it's all extrapolation, built on the assumption of the universality of this method, of some things that are being done. And they'll find out that it works in the stars just like it works on Earth. So that doesn't strike you as strange, but in that world that would have been completely at odds with the received view.
How is there not a contradiction on those two? Aren't they falling into the same trap that Aristotle fell into?
Yes? Mm-hmm.
Because they're only setting up a system that he set up, and they make paradigm shift and all they're going to set up.
So, right, but the universality will be one fundamental characteristic of scientific revolution. Now notice, by deep in the 20th century, the 1960s and 70s, and the 90s, this will be called a question. The inner New Age assumption in science. Well, call it the breakdown of complete causal explanation or the quantifiability of reality. That there's some dimensions of reality that cannot be examined. Well, then you can deny it there. What about demons? What about mind? What about God? What about angels? See, when people have trouble with scientific worldview, don't lay on them 4 series of sermons on Satan and demons. It'll be quite problematic. See, that's over ontology. What exists? If you believe the Bible, you might believe that. But see, the biblical worldview is going to get kaput here in this very century of development. The whole worldview. It's odd that it takes a little longer for biblical criticism to reach, but people held the Bible, away from all that for a little while. But by the time it reached the Bible, the whole history of biblical criticism in the 18th, 19th, 20th century. Okay. Now, 17th and 18th century, that's where we were at the beginning. We've gone from change to revolutions in thought. We've gone from mere incremental investigation of things, doing things that no one previously had done, taking thought to a revolution, a way of doing things that advanced everybody's capability. So in this context of the 17th and 18th century, you have political revolution, you have the French and American Revolution, you have the Industrial Revolution, the technological and sociological revolutions that changed the family structure. See, crisis in family structure started in the Industrial Revolution. Not in the 1950s and 60s with West Side Story, or not with slums. See, London was half slums. Paris was half slums. So slums do not create these things. The people that live in them create them. You have to deal with it. Now, an authoritarianism versus a new spirit of inquiry. And this method and the universality of this method will be fundamental for that. It is for this kind of thing here. Development of national academies out of philosophical inquiry. Now, the British Royal Academy was created in 1660. Now, just take that as kind of a date because the scientists are removing scientific investigation from the church's control. That, in essence, is what these new academies are about. The church controlled everything. They create academies to keep the church out. It's very important. There's high-level work already done, but if you haven't read them, they haven't been done for you. On the British Royal Society, the first Royal Charter was 1662, and Newton was its first president, and he wouldn't let anybody be president until he died. The French Académie des Sciences in 1666, the French Academy. Now, Laplace was head of the French Academy. 1662 British, 1666 French, and the Russian Academy at St. Petersburg, 1724. 1720. So you get a spirit of removing scientific investigation from the church's control. That's all that I mean by those little remarks for now. Now, the development of the practical utility. This is I'm mentioning this only because the events of the past month have demonstrated once and for all the inability of Marxism to deal with the realities of the world. But Marx's thesis, Burnell set of books, that's a Marxist set of books on the history of science, and the Marxist thesis is that science advances when man has a practical problem, he creates a solution. But you see, you'd have to be very brilliant to write the history of science that way. Because science didn't, as a matter of fact, develop in that manner. But Marxism, see, a socio-economic, political, causal structure, says that man creates what is functionally necessary. That person can't have any awareness of the actual origins of science. But that is a classical Marxist viewpoint. That science developed, you mean man never had a practical need till the 17th century? See, you've got to be dumb to make a remark like that. But that's a classical Marxist viewpoint of the origins of science. Man has a practical problem and he devised science to meet it, as though he just started getting practical problems when he devised science. That doesn't explain the origin of science, by the way. Now, practical utility of revolutionary discoveries, but don't forget that there was no immediate practical discoveries of the astronomy and the physics, and immediately chemistry, geology become more practical. But see, the method was developed in physics and astronomy. The method did not have immediate practical relevance to the masses of Europe at all. But it was this method that was applied to economics, to politics, social theory, to everything. The method was applied. But the method was here. See, pragmatism can't survive this, because this material, when you're talking about photons, that's for all practical purposes, not a big caller. You're not going to fill the chapel Saturday calling the elders together to discuss the consequences of photon analysis. Though the Christian faith stands or falls on certain consequences of that, but they wouldn't know about that. Sailing ships, awareness of forces of atmosphere to chemistry. See, where you're going to get a barometer. Well, we haven't had barometers for thousands and thousands of years. Okay? But without chemistry, without physics, there would have been no barometer. See, air pressure. Well, how do you know there's air pressure? How do you measure something you can't see? And first thing you do in grade school chemistry is, well, not first thing, but second day, teacher will show you the chemicals that have no taste, no smell. Okay? Now, density of air. See how practical? Who cares about the density of air? Is there any immediate practical relevance that everybody in Europe was clamoring for insight on the density of air? See, they don't even know what air is. Air is a Greek word into English. There is no such thing as air. There's stuff. Now, there's oxygen, but then there's junk in the oxygen, you know. Now, variations of air pressure with height above Earth, see, practically, but it's a philosophy of mind that starts deducing consequences of these things. Another simple little thing, variations of air pressure submerges the bottom of the ocean. So you're getting ocean capabilities, you're going to get the submarine out of this, and you're going to get airplanes out of this, and you're going to get a lot of things eventually out of some of these things. Next is development of mining and the need for water pumps. Now, the theory of pump, what is the essence of a theory of pump? Vacuum and what? Pressure. Well, see, you know what a pump is now, but see, they didn't have pumps. So, air pressure, vacuum, pressure on tensile strength on different kinds of, you know, do you have, do you put sludge in a thermometer, or do you put mercury? Why do you put mercury? I don't mean you need to know that, but why do you put that? Why don't you put something else? Now, it's not only heavy, but what? No. Developments of mining needs for water pumps. Now, Galileo observed the limit in height of a column of water which could be produced. Now, Galileo recognized that pressure just natural pressure, that water could only rise to a certain height. What that got to do with the pump? What if you needed 100 feet? Well, then you'll have to have energy help to boost it. Simple little things like that. Now, Galilei and Torricelli related the atmospheric pressure, which led to a barometer and vacuum, aided by Pascal. Von Guericke developed the air pump with partial vacuum, and I can still see that picture of those horses, team of horses, trying to pull that vacuum pump apart. See, they couldn't pull it apart. See, the vacuum. Well, what is a vacuum? Well, it's nothing. Well, when you get physics of light, and matter reduced to light, and light reduced to energy, and matter vanishes before our eyes as completely immaterial and way past any empirical availability. All these things have devastating consequences for epistemology and the whole Christian worldview. Hook, Captain Hook, you remember him from Broadway? He improved Galileo's design in making an air pump, and Boyle, B-O-Y-L-E, Boyle experimented with the air pump. Boyle developed the idea of gas pressure. We're on the way to chemistry. We'll get to that in a little while. Boyle's law, pressure exerted by gas, the volume contained. Boyle's law, or the marionette, rediscovered it independently. The French chemist and the French physicist. Concept of gas, von Helmholtz, 1577 to 1644, the concept of gas. What we're doing is getting what? Different forms of what? Forms of matter. Now, are there different forms or different characteristics of matter? See, is everything... Now, you didn't Xerox it because I counted how many Xerox, but I have a periodic chart. It's slightly dated on this. But on the periodic chart... Now, Bill, there would be some new things that belong in this periodic chart. Did you look at it? I think there's two more things. There may be more. But see this? Form. Is it just different form? See, matter, by the time the periodic chart came into existence, we have the whole foundation for materialism. That if all matter was made up of one or some composition of these building blocks, there wasn't any place for spirit, there wasn't any place for all the things that Christians had talked about. It looked like you had a complete, exhaustive scientific explanation for everything in the universe, including man. Well, just keep preaching the Bible. It'll go away. Okay? Concept of gas, Boyle's skeptical chemist. How many of you had any reason to have read Boyle's skeptical chemist? Now, Boyle is the first one to distinguish between mixtures and compounds. It seems so simple. Mixtures and compounds. Vital is the Greek view that essential constituents of matter continue to influence chemical thought for nearly a century after Boyle. That's why we need this list, and I'll get that list, but these two I put up for tonight. The concept of the atom in classical thought, inherited in the Christian community from the start, is that matter was ultimately invisible. Now, you wouldn't empirically be aware of that. Okay? And it was indivisible. And when do we have to wait before even the greatest minds in science say that the atom is not indivisible? Come on. Now, I was going to say 4, but that's correct. Now, we have to come into the 20th century before that Greek view was abandoned. We're talking about the biggest minds in the world. We're not talking about high school teachers. We're talking about the creative minds in the sciences. Turn to the 20th century before this indivisibility. So the Greek view held on a long time. Now matter, all these things development of quantitative approach to chemical reactions, stoichiometry, played an enormous part in the development of chemical theory. What's that? Well, how are you going to know? You're going to do quantitative analysis, and you won't know if you have the code, you know, CIA computers can break down. Quantitative chemistry, you weigh. See, how many have done chemistry, physics, and things? Yeah, that's enough here. Now what you do is start weighing things and count and measure. Well, that's going to be extending this science. Is going to have to weigh it, and it's going to have to measure it, it's going to have to quantify it. What's going to happen to the Holy Spirit and spirit talk and soul talk in psychology? See, the social sciences lose the soul in 19th century psychology. Now, Christians can still talk as though nothing's happened, but that was most of the
process.
Yes. See, that's why the books of this nature, see, coming from people that we don't expect to say these things. So I've had a seminar in the philosophy of mind, and there were fewer than 1,000 students in the last time that was happening. Had not any notion how important that was for Christian reading of reality. Because it just didn't fit anything that I'm doing. Now, Priestley, 1733 to 1804. You put Alexander Campbell there. Priestley, he experimented with gases, developed techniques of collecting them in glass jars over water. He collected gases over mercury, isolated gases of hydrogen, chloride, and ammonia, and highly soluble in water. Now, we don't have a chemical explanation for why things are highly soluble in water. It's over the molecular structure that you know from high school. See, now, but see, when these men were creating the parameters, they didn't go to any school to learn how it was done. See, there's a difference between learning what someone already knows and creating information that no one's ever known. Isn't it? Okay? So don't confuse training with education. Now, physics, theory and practice. Scheele, S-C-H-E-E-L-E, also Priestley, independently isolated chlorine and oxygen. They do not have atomic numbers or atomic weights on them. See, we don't have the periodic chart. But once the periodic chart, the paradigm shift occurred, why things they didn't even know about were predicted. Well, the prediction was possible because the universe was structured. So when New Age says it's not structured, the whole history of the hard sciences rebel against that. And when you read Peter Berger and Luhmann's Social Construction of Reality, it ought to serve. It couldn't be a very large book. The social construction of a little bit of reality. Because jealousy is real, isn't it? And that creates... But all of reality isn't socially constructed. It's very important for the gospel and cross-cultural communication. Should we have a theology for every culture? Not on your tin pipe. Culture does not determine what the gospel is. It at best determines how that gospel can be heard, but it doesn't determine what the gospel is. Now, the Swedes, Scheele, 1742 to 1786, Cavendish at Cambridge, 1731, 1810, experimentation with air. See, they don't know that air is what? Oxygen. They don't know that. They will know it, but they don't know that up to this time. The Greek word air. And this comes into English like this. Well, air, what that mean? It's not a scientific word. You can't tell what's in air just because you think you can. Water is a compound. Now notice, it's only been in the 18th century that the human mind ever devised that there was a compound, and there's a difference between a mixture and a compound. And you know something about valence, and you know some things are bound and some things are loose in the structure. Why certain things go together. And Cavendish experimented with air and water is a compound of two gases. Now notice, here's a very important thing. How do two gases become liquid? Now notice the difference between the nature of gases and then under certain conditions, the characteristics of gases. The gases are not they're not liquid. Well, just the thing we drink. Well, some of it's H2O, see? This depends on how much sludge is in there. you know, all the things that are deadly for us, but God's providence, He'll keep us alive long enough to solve that. So you've got Priestley, chlorine, oxygen, oxygen and nitrogen in the air, and Lavoisier, let me spell that because it doesn't look that way en français, Lavoisier, Lavoisier was a source of radical change. Who is Lavoisier? Some of you would know that. All right. Now, the phlogiston. Let me spell that word. I'll keep strange terms other than names. Phlogiston. Does anybody here know the phlogiston theory of matter up to the 18th century? Well, it was over the nature of matter and how matter moves, and how matter moves and changes from one set of characteristics to something else. See, Aristotelian metaphysics said matter and form. The form, there's a material cause and there's a formal cause in Aristotle's four-pronged theory of cause. See, the mass is interpreted with Aristotelian metaphysics. See, it looks like to the eye that it's still, well, probably wine and bread, but when the priest genuflects and the little red light goes on, it's the body and the blood of Christ. See, it has two sets of accidents at the same time, which violates even Aristotelian explanatory power. So it tastes like and looks like bread and wine, but it's really, see the ontology? All over language, this is my body. So you get literalism, see, in premillennialism, but the whole mass developed over the hermeneutics, over the use of language in Greek and Aramaic. So gases combine. Now, some are good for you and some are deadly. Where do they get their what? Where do they get? You don't need to answer that, but you see what's coming? See, something that man has never even questioned in the past. We'll have a little talk about scientific medicine. Scientific medicine couldn't develop until scientific chemistry developed. When scientific medicine develops in the 18th and 19th century, that would displace the priest that's taking care of everything. And then health will be removed out of the church's hands. And in the 19th and 20th century, it'll be put back in. I hope enough preachers are sued, so enough of them be put in jail if they stop telling people they'll help them when they don't help them. You have to get at the cause. You can't band-aid crisis. And so Antoine Lavoisier, 1743 to 1794, demonstrated that the products of combustion were on the way to chemistry, had exactly the same combined weight of oxygen used in the reaction. You'd have to weigh it before and after. What it looked like, now notice, you're on the way to a materialistic view of matter, that matter was nothing but what could be weighed and measured. And that will become the scientific. And faith has nothing to do with quantitative or qualitative chemical analysis. Faith will have nothing to do with barometric reading. See, faith will have nothing whatsoever to do with the actual state of affairs. So progressively, faith talk that's been present in the West will be what? You already know that. Now, brief survey of the foundations of modern chemistry. So we get to Newton. The foundation of atomic theory, Dalton, the Dalton gang. They went criminal on it. But Dalton was the first man, the top of the 19th century, to propose an atomic theory of the structure of matter. Dalton. And that information was available. Then next, the periodic table of the elements is unfolded. Then the emergence of organic chemistry and analysis of types of compounds. Then in the history of science, electromagnetic synthesis is developed. Then the rise of physical chemistry, the fusion of physics and chemistry develops. And then the breakdown of classical physics. Now chemistry in the 18th and 19th century, three major themes dominate chemistry in the 18th and 19th century. One, all matter is formed from chemical elements and their compounds. All matter is formed from chemical elements and their compounds. Now you see, you're headed for nothing but. You're headed for materialism, that science can handle everything that is about reality. So anything that's not reducible to this scientific paradigm will not be real. By the time psychology and psychoanalysis develops in the 19th, 20th century, what happens to religion and God? It will be placed in an illusionary category. And then that'll be wiped out. The self will be wiped out. See, the loss of the self is the ultimate consequences of reductionism. The rise and fall of the self, what the essence of the history of the social sciences will say. Now, two, the scholastic idea of principles. Now, watch that. Scholastic idea from Aristotelian principles to the idea of separate, isolatable substances. See, the Greeks talk about principles, but principles are what? That's not one of the 8 things, but I'll have that to do later. These are abstract notions, metaphysical notions. And the metaphysical abstractions will be replaced by what? Measurable natural law. Well, physical law, not natural law. It's another thing. Okay? That's what's happened. Lavoisier's textbook, first published in 1789, listed 23 elements. We only thought there were 23 things. But by 1849, Gemelin's Handbook on Chemistry was based on 61 elements, 49 metals and 12 non-metals. So between 1789 and 1849, approximately how long? Just technically, half a century. You've more than doubled, and that isn't even all of it. Now notice, this will be the fountainhead that science and principle can tell you anything that's true about the world. You apply the method, and you will find out what's there. You don't study the Bible in English, Greek, or Hebrew, or practical ministries, or anything else to find out about reality. You study it scientifically. Isolation of new elements, another factor, via techniques of electricity. You know about electrolysis. I remember that in the 4th grade. I'm sure it's probably in the 2nd grade now. Now Davy, D-A-V-Y, isolated sodium and potassium by electrolysis. Isolated sodium and potassium by electrolysis. And Mendeleev, let me give you that name because he is the father of the periodic chart. M-E-N-D M-E-N-D-E L-E-E-V. Mendeleev's periodic table. Russian. Mendeleev interpreted chemical behavior, now listen, in terms of subatomic structure. There's not a relationship yet between the stars, this field, and this until chemistry quantifies, and the assumption would be that matter that this is about and matter that this is about is quantifiable, and therefore you have in essence sermonically materialism. There's no place for soul talk, there's no place for God talk, immateriality talk. Now in the context of the Newtonian world machine revolution, what name do you know, maybe from some source reading, Bishop Barclay. It's Berkeley, California, but it's Bishop Barclay. What did he do? Esse is percipi. To be is to be perceived. He devised the immateriality of matter theory. Well, that was absurd. They knew he devised that because he believed in God. But we come down to Norwood Hanson, 3 PhDs, 6 MAs by 32. And he says contemporary quantum mechanics says that matter is immaterial, but not in the Berkeley sense. Because Berkeley couldn't explain. See, Berkeley was on an apologetic bench, but he didn't advance science. So we may do God harm trying to help God, trying to defend something the Bible says and be misinformed about both what he says and how to defend it. Okay. Now another, chemical composition between 18th and 19th century. Laws concerning quantitative portions in which elements would combine together to form compounds. Now the Greek view of atom, Democritus's view, and Democritus was the head of the physics department at MIT and Harvard and Stanford and Berkeley and at Los Alamos. Now he said atoms were discrete particles. What is a discrete particle?
Unseen.
Now notice, well, it's unseen, it's indivisible, and it's a discrete particle. Well, that's way past empiricism, isn't it? But you see, they were seeking for what? What word up here were they seeking for when they said all physical reality is composed of discrete particles? What were they seeking?
Universality.
Universality. You see, if science doesn't devise a universality, you don't have science. You might as well have a witch doctor. They're getting something that everything participates in, that is studyable, explainable, and quantifiable. And if it isn't studyable, it's not quantifiable, it's not measurable, it's not scientific, it isn't a candidate for being the truth. See, this is one of the reasons why the church, conservative churches, our brotherhood, has lost truth claims in the Bible. We can't just have truth in our heart. Can't just have existential truth. Scientifically false, but it's existentially so helpful. That's pathology. Now, the Greeks, Democritus, discrete particle, but they were looking for universality, and that's all. This is just a sermonic presentation. And Dalton's atomic theory made sense of quantitative results. Out of these brief steps, Dalton opened up the philosophy of chemistry that all components of matter would be quantifiable. You could do quantitative analysis and qualitative analysis of it. And what was the result of that? It could. But that presupposes that the universe is, yes, ordered. You see, one morning you went to the laboratory, and the simple and stable elements up in the left-hand corner, they changed, and they were now in the middle. And tomorrow they're going to be down here in this corner, highly complex and highly unstable. But they're not. They're always in the same place. What might that suggest? Chaos as a model? Sometimes design. But I have this very valuable book up here. Right up here. I'm sure I have. Right here. Nebraska. This book is a very important book. How to train the teachers to get it. Human movement on the design argument. Because it is after humankind that the cosmic design argument, based in Newtonian analysis, that problem was removed. The design argument is attacked, and in Hume and in Kant. Neither Hume nor Kant denied there was design in the universe. See, the most atheistic pharmacologist at Champaign, at the medical school, wouldn't doubt that there's design, or you couldn't do pharmacology. But they would deny that there's cosmic design. Well, we're about to lose God. And do it? You bet. Always good. But see, they're so impractical to most people, they haven't any idea that it has anything to do with their faith. Because they have faith in faith. Some people have faith in the preacher. Some people have in brotherhood leaders. Those are all bad news there. God will not be a happy puppy if that continues. Now, Dalton's atomic theory was based on the assumption that all chemical compounds and chemical elements would be reducible and studyable, and on the basis of that assumption, see, he didn't have proof of that, he assumed that, because other men had shown that you could do this, and you could do this, and you could do that, and it all worked out. And you don't actually get the same atomic number, and you don't get the same atomic weight, because these are statistical numbers. What that means? Well, that means that in that laboratory you do an analysis, and you would have to extend it to 3 places or 4 places in the logarithm, because all examples of the things in the periodic chart, and we'll have a break, all examples in the periodic chart are not of the same month. From high school, you couldn't get out of a high school without something. Well, that's another matter, Bill. I'm expecting great things of you. Well, see, as a matter of fact, every laboratory examination of these material building blocks don't have the same exact number. But the numbers in the physics, I'm going to have to get a $100 physics handbook. I had one when I was studying this, but I haven't had one. It's not a big call for that. So you get statistical statements. So Bill and those of you that have done science, you have a physics handbook, but the numbers in there, see, are statistical statements.
Probably.
Well, high-level probability, but see, statistically plus or minus a variable error, that just means that there's no absolute certitude that that is the case.
They're averages.
They're averages. See, it's like the density of gold, or the density of any metal. That is an average statement. You have no way of measuring because the pressure and temperature in different examinations is slightly, it's about the same, see, but about doesn't sound very scientific. That sounds like theology or something about. Or practical ministries. It's about this. 2 things. Atomic theory as a method for analyzing and synthesizing compounds. Worked out. Atomic theory, Dalton. Then the next thing to develop was the concept of the molecule. What is a molecule? More than one atom? Well, that's not all. Now, molecule is some kind of compound. That's not false, but that's not enough. See, you got more than one atom on the periodic chart, but they don't make them molecules. Concept of molecules then concerned how individual atoms, we're on the way to materialism, individual atoms were linked together to form molecules. See, we got to get heat right, magnetism going. How do molecules combine? What moves molecules? Not just what moves the planet. What moves the molecules? Well, when we're done, or when we stop, we won't be done. The laws that move the heavens are the same laws that move the earth. So don't worry about chaos principles. The whole history of concrete scientific advancement is one long list of this. Instruction. Now, the social parameters, there is some construction of reality. You got different cultures, different things. They build houses differently, they do different things, differently. But see, that's not most of reality. They don't determine the chemical composition of the sun. They don't determine the law of gravity by social construction. They do not socially construct Mendeleev's chart. They do not do atomic theory by social construction. Well, you see, it's about the truth. See, and we've got to have some perspective of this.
It's just not really science, but he was taking principles of science and bringing them Bible, you said philosophical, you don't get in terms of how that into religion, and that's where you can...
Right. See, the chart that I gave you first, that's last, because classical liberalism in the 19th century will assume a certain model of science has once and for all removed. See, in the disciple, the heretic, they've assumed that a real education would remove anybody from believing the Bible. That one can't both be informed and believe. Those are mutually exclusive propositions. You're either ignorant of what's going on, and you believe in spite of what's going on, which means faith is stupid. Now, structural chemistry, the shape of molecules in three-dimensional space, was invented. Now, what does time and space, polygrams, time and space have to do with the structure of a molecule? You see? See, different molecules are structured, huh? Well, what does time and space have to do with that? That's not very practical, is it? We take a little break, come back to major contributions in the development of natural chemical reaction, periodic elements, and the Newtonian world machine. By the time we get to organic chemistry and electromagnetic synthesis, we have the world machine on our hands. Okay? So don't go far, or stay long. Huh?